Welcome to the first party line maths video. Today we're looking at question 12 from chapter 15H of the Specialist 1-2 Maths textbook. Here is a question above, and all we need to solve this is the Pythagoras theorem. We can visualize the four congruent spheres on the table as circles to begin with, to create the square. We know that each circle has radius 10, therefore each center to center is length 20. From here we get a square, and this square is where the center of the fifth square sits upon. 20, 20, with a circle sitting inside it. To find the midpoint of the circle, we then have to draw from within the square and figure out how far it is from each of the circle's centers. Using the Pythagorean identity to find the length, we get 10 squared plus 10 squared equals length squared. From this we evaluate to 10 root 2. From here, now we know the distance. We also know one other identity. If we have one circle touching another circle, their center to the other center, assuming the circles are the same size, is twice the radius. From here, we can form the triangle of 20, 10, root 2, and we try and find the height to the midpoint of the above triangle. From here we do 20 squared minus 10 root 2 squared equals h squared. Therefore, h equals 10 root 2, the same as the diagonal. From here we know there's 10 centimeters to the midpoint of this triangle. To the midpoint of the circle, we know there is 10 root 2 to the midpoint of the other circles, and we know there is 10 more centimeters from that midpoint to the ground. The result of this entire height is 20 plus 10 root 2. This results in approximately 34.14 centimeters as our final answer.